Which machine should I use? Part 2, the laser cutter. Laser cutters are older technology than 3D printers, and it just doesn't sound as exciting. They're also limited in that ours can only cut in one plane, and your parts will be the thickness of whatever sheet of material you are cutting from. Laser cutters are capable of making complex 3D shapes, but the designer needs to create a series of parts made of the available thicknesses of sheet material that assemble into these shapes, kind of like a flat pack of IKEA furniture. It takes a little more effort in design than 3D printed parts do, because you are operating under these design constraints. Our laser works well with wood, acrylic, and fabrics, but it doesn't work on metals like a high-powered industrial machine would. The laser cutter is extremely precise and has near identical repeatability, again within fractions of a millimeter. You can cut parts as big as 900 by 600 millimeters and as thick as about 10 millimeters. While the laser cutter isn't fast by high-speed production standards, the laser is much faster than the 3D printer and is actually useful for serial production, provided that your production run is in the tens to hundreds of copies per day, not thousands. The box for our coding projects took about 15 minutes to laser cut. About half of that time was used for the engraving of the lettering and graphics, which is a little slower than a straight-up cut. The laser is also capable of etching graphics and photos onto surfaces, or even carving them into a surface. You can literally put your face on your work. Like the 3D printer, the laser cutter has the advantage that it doesn't require expensive dedicated tooling to make parts, like a high-speed stamping press would. The drawbacks of the laser cutter are that it requires additional support machinery, such as pressurized air and significant exhaust ventilation, and that it's sometimes difficult to find uses for the oddly shaped remnants left in the sheets after we've removed our parts. We try to cut small items from these remnants and dispose of the sheets when they're at least 90% used up. Like the 3D printer, the laser cutter operator inputs and the software that converts CAD files to cut files can be learned very quickly. Unlike the 3D printer, the laser cutter is not a machine where a student can quickly reach the stage of unsupervised use. While it has interlocks that prevent it from producing a laser beam with the door open, it does literally vaporize material. If the wrong material is cut, this can create toxic or corrosive fumes. If the material is too thick, the air setting is incorrect, or the power setting too low, it can set materials on fire rather than cleanly blasting through them. An unquenched fire could spread to the building, creating a very dangerous situation indeed. As the consequences of such a failure are so high, considerable training and demonstration of skill is required before a student can operate this machine without direct supervision. But as you can see from the photos, the laser is a very versatile and capable machine. It is also by far the most popular making machine in the lab, probably due to the fact that the make step is a few minutes at the end of a few hours of designing instead of a few hours like a 3D printer. It could also be that the things that it makes are very polished and very professional looking. See you in part 3, where we'll cover the vacuum former.